Hey students, welcome back. This is Torres, Elbow Bump. How are you? Are you doing okay? Is your family okay? Remember, if you need something, please send me an email and I will do whatever I can to try to help. So lucky you get to hear my voice for another lecture. But the best part is we're going to be doing another example on how to use the 4 steps of hypothesis testing when you have the population mean and the population standard deviation. Yay! So here are the 4 steps to hypothesis testing. Let's talk about each one just as a brief review. The first step is to write your hypotheses. You're going to write your null hypothesis, which is the one that describes the status quo, what we expect in the population, and you're going to write your alternate hypothesis. The alternate hypothesis addresses the question. Whether you're working with proportions or you're working with means, you're going to use the notation that describes the population parameter. The next step is usually the longest step, and that is the prepare step. So during the prepare step, you're going to do a variety of things. You're going to choose the significance level, and you're going to find the test statistic for that significance level. To do this, you will also need to decide whether you need a 2-tailed or a 1-tailed test. And if you need a 1-tailed test, do you need a left 1-tailed test or a right 1-tailed test? You may have to calculate the standard error for your sample during this time as well. You might also need to check the assumptions to make sure your data is normal. So unless something is already stated in the problem that tells you to assume normality, then you would have to check for the conditions of the central limit theorem. This is also the time where you want to make yourself a model and establish the area of rejection and the area of retention. The next step is the compute to compare step. In this step, you are going to calculate your Z obtained using the sample information, the population information, divided by the standard error that you calculated for your sample. Once you calculate your Z obtained, you will compare it to the test statistic that you got in the prepare stage, which is called the ZCrit. And also, you're going to compare it with the model that you created. If your Z-score falls in the area of rejection, this is evidence that the null should be rejected. Also, this is the time where you will calculate the p-value for your test statistic, for your Z obtained. If the Z obtained's p-value is less than your significance level, or your alpha, then you should reject the null hypothesis. It's important that your obtained Z falls in the area of rejection, and also your p-value is less than your alpha. If you get mixed results, something went wrong. In the last step, you're going to decide whether you will reject or whether you will fail to reject, in other words, retain the null hypothesis, and you state your conclusion in the context of the study. So in today's example, we're going to be talking about tennis players. The scenario says, a health researcher read that a 200-pound college-aged male can burn an average of 524 calories per hour playing tennis with a standard deviation of 45.9 calories. 37 college-aged males were randomly selected at a commuter school, and the mean number of calories burned per hour playing tennis was 534.8 calories. The question is, do college-aged male tennis players at this commuter school burn more calories per hour than the college-aged male tennis player population? Test with a 1% significance level. So I have copied the information into Ziteboard. Remember, the Ziteboard information as well as the Google Slides are linked in the description box below. Another thing that you'll find in the description box is a document with common significance level ZCrits and also the normal distribution calculator that we found for free online. Awesome. So I'm going to go ahead and read the problem one more time to make sure that I understand it and I can get going on this. Okay. A health researcher read that a 200-pound college-aged male can burn an average of 524 calories per hour playing tennis with a standard deviation of 45.9 calories. 37 college-aged males were randomly selected at a commuter school, and the mean number of calories burned per hour playing tennis was 534.8. Do the males at the commuter school burn more calories? Okay, so there's an important word, more calories per hour than the college-aged male tennis player population. Test with a 1% significance level. Okay, well, first things first is I've got to write my hypotheses. So here we're talking about an average, right? So we know that this is going to be in terms of means. We're not talking about a percentage. There's no proportion at all. So our H naught is going to state what we see in the population, and we're using mu because this is regarding a mean, and the mean is 524. And the alternate hypothesis is looking to see if the sample is more than 524. Why is this the same? Well, these are the same because it's the population information. We're using mu because it's a mean, and more because we're just concerned with it being more than the population. Okay, not less, not different, just more. Now we're to the prepare stage. So I'm going to go ahead and change colors of my pen because I'm going to do prepare in red. Notice I keep picking the same colors. I'm hoping this will help. And we're going to go ahead and start preparing for our test. So they gave us a significance level. They told us that they wanted us to use a 1% significance level. So we are risking committing a type 1 error one time out of every 100 trials. That seems a little bit excessive, but I would have personally chosen a 5% significance level for this type of study, but let's just go with it because it allows us to use different types of significance level for practice. So we're going to go with that. All right. So the other thing that I need to write down is I need to write down how many people in my sample, 37. And I need to write down what my sample mean was, which my sample mean was 534.8. That information is right here. I'm going to go ahead and write my population mean and the population standard deviation, which is 45.9. Okay. And now let's start getting the other information. So let's see, what kind of test do I need? I'm going to make this a little bit, move this over a little bit. What kind of test do I need? Do I need a left one-tailed, a right one-tailed, or just a two-tailed? Well, this is just looking for values that are significantly greater than 524. So I'm going to be looking for a right-tailed test. Right one-tailed test with a 1% significance level. So I'm going to go over to my ZCrits for common significance. I'm going to go down to where it says right one-tailed test, and here is my significance level. My significance level is positive 2.326. So my ZCrit is positive 2.326. Okay, fantastic. I'm going to go ahead and start making my model. And I want to know, here is my model. Red. Here's my model. My curve. And here are my z-scores. Z. Okay, so here's my model. I've got my z-scores. I know that when I start making this is going to be 524 is going to be in the center because it's going to reflect what we know from the population. But the problem is I don't know if my data is normally distributed. It doesn't say anything about normality. So I need to check it with the conditions of the central limit theorem for means. The first condition is that the sample was randomly and independently selected. And I do have information about it being randomly selected right here. I don't have independence, RNI, but I'm going to go ahead and give it the benefit of the doubt. So we're going to go ahead and say that that condition is met. The second condition is a sample size condition. And the sample size has to be bigger than 30. I'm going to scooch this up a little bit, give myself a little bit more room. So we know that our sample size is 37. And 37 is greater than 30, so that checks out. The last condition is the condition of a large population. Here I go scooting back up. My population size has to be at least 10 times bigger than the sample. So my population has to be at least 10 times bigger than 37. So my population size has to be at least larger than 370. So do I have at least 370 college-aged male tennis players in the United States? I'm willing to say yes. I don't know exactly how many, but I'm willing to say that there's more than 370. So we can say that all the conditions of the central limit theorem have been met, and we can assume normality. If we can assume normality, zoom us in now, then we need to find what this distance is here. Right in here. Okay? We have the standard deviation for the population, and we need to find the standard error for our sample. So we're going to do the standard error is equal to the standard deviation of the population divided by the square root of the sample. So our population standard deviation was 45.9, and I'm going to divide that by the square root of our sample size. And I'm just going to bring this over to Google Calculator and go ahead and do the math. So 45.9 divided by square root of 37 equals, and I get 7.545. So I'm just going to go ahead and just say 7.5. Okay, great. So I know that this area is 7.5. I'm going to go ahead and just make it easy for myself and say 8. Okay, so that I can kind of start to plot this thing out. So this is going to be 524 plus 8 is going to be 532. And I'm going to make this bigger so that I can write in here. So this is going to be 532. And then another 8 is going to be 540. And another 8 is going to be 548. If I subtract, then this is going to be 516. And if I subtract again, I'm going to get 508. And if I subtract again, I'm going to get 500. Okay, so here I have it all laid out. Now my ZCrit, we said was going to be 2.326. So I'm going to go ahead and do this in blue. My ZCrit was 2.326, which is up here. So if I get anything that is greater, if I get a Z obtained that is greater than 2.326, I'm going to reject. And if I get anything less, if my Z obtained is less than positive 2.326, I'm going to retain. Okay, so that's the prepare phase. A lot to do, right? Now that we've completed our prepare phase, we're going to go into the compute to compare phase. So in order to compare our ZCrit to the Z obtained, we need to calculate the Z obtained. So I'm going to go ahead and again do this in pink. I want to keep this consistent and go ahead and calculate my Z obtained. So my Z obtained is going to be my sample mean, and from that I'm going to subtract my mu, my population mean, and then I'm going to divide that by the standard error. So I've got my Z obtained equals my sample mean is right here, so that is 534.8, and I'm going to subtract my population mean, which is right here, 524, and all this is going to be divided by my standard error, which is right here, and that is 7.5. So I'm going to go ahead and go into my Google calculator. Got my Google calculator right here, clear, clear, clear. And I've got 534.8 minus 524 equals, that gives me my numerator, and then I'm going to divide my numerator by 7.5. And I'm going to get that the Z obtained is 1.44. So let's look to see where 1.44 will fall in my model. 1.44 is here. And it is in the retain section. Okay, right now it's looking like we're going to retain. The last thing I want to do is I want to check the probability of Z obtain, and we need for that to be less than our significance level of 0.01. So went over to the normal distribution calculator. Remember, the link is down below. This is a free link. The population mean is 524. The standard deviation, we're going to be using our standard error, which is 7.5. And we're just looking for the probability of an amount being greater than 534.8. And I'm going to go ahead and hit show me explanation, compute. And I get a p-value of 0.0749. Now, when we set our significance level, we set our significance level at 1% alpha. So that means that we were willing to risk committing a type 1 error one time out of every 100 trials. This is saying that you are risking committing a type 1 error 7, almost 8 times of every 100 trials. So you don't want to reject here. Let's look at our picture. Here is the mean, right? Our first deviation is going to be over here, and our second deviation was going to be over here, and we had a little bit more, and we said that anything greater than that we would reject. The area under the curve at 534.8 and beyond is not less than what we were willing to give up. So this still falls in the area of retention, so we're going to retain. Okay, so my alpha was 0.01, and I said if anything was less than my alpha, I would reject. But this number is greater than my alpha, so I cannot reject this. I need to retain the null. So my Z obtained is in the area of retention, and my alpha is smaller than the probability of the Z obtained, so I'm going to retain the null. The final step is to make a decision on whether you're going to reject or retain the null, and also state the conclusion in context of the study. So we have decided that we're going to retain the null, and if we were going to state this in the context of the study, we would say that there is insufficient evidence that the college-aged men at the commuter school burn more calories playing tennis than the general college-aged male population. So let's summarize. The question was, do college-aged male tennis players at the commuter school burn more calories per hour than the college-aged male tennis player population? So we had the information here where the population burns 524 calories per hour with a standard deviation of 45.9, and they randomly surveyed 37 males at this commuter school, and they burned 534.8 calories. So when writing the hypothesis, we needed to make sure that we wrote the null according to the population, and since we were dealing with means, we were going to use the notation for mu. The question asked, are the men at the school burning more calories than the regular population? And so our alternate hypothesis was mu is greater than 524 because the alternate hypothesis is addressing the question. In the next prepare phase, remember this took the longest time because we had to look stuff up and we had to check the conditions, etc. So we wrote down all the things that we needed. We decided we wanted a right one-tailed test because we were just looking at values that were much more greater than the expected norm. So we were looking at for a right one-tailed test. We found the ZCrit that matched a right one-tailed test for the significance level of 1%. And we found that that ZCrit was positive 2.326. Okay. Then we started to create our model. We created our model and we noticed that there was nothing in the scenario that stated that the distribution was normal. So we went ahead and checked normality using the conditions of the central limit theorem. We found that the scenario met the conditions of the central limit theorem, so we were good to go. We could assume normality. We went ahead and finished making our model by putting the population mean in the center and using the standard error formula for means when the population standard deviation is known. And we plugged it in to find the standard error for our sample was 7.5. And we just kind of rounded it up to 8 because we wanted to make just a general model here. We calculated our theoretical raw scores to go here. And we went ahead and marked off our ZCrit of positive 2.326 here, and we said anything to the right of this we were going to reject, and anything to the left of this we were going to retain. In this next section, we decided to go ahead and start computing everything out. To calculate our Z obtained, we subtracted our population mean from our sample mean, and then we divided that by the standard error. Once we plugged in all the numbers, we found that our Z obtained was 1.44. This falls in the area of retention. So the Z obtained fell in the area of retention. Next, we used technology to find the probability of the Z obtained. We found that the probability of the Z obtained would be 0.0749. Since this number, this probability, is greater than our established alpha of 0.01, then we would retain the null. So here again, we decided that if the p-value is less than alpha, we're going to reject. We didn't get that. We got the p-value was more than alpha, so we're going to fail to reject, or another way to say that is retain. To state the conclusion in the context of the study, we said there is insufficient evidence that college-aged men at the commuter school burn more calories playing tennis than the general college-aged male population. So what's the big idea? Today's big idea is that the 4 steps of hypothesis testing provide a systematic process to answer the research question concerning the population parameter. The 4 steps are hypothesis, prepare, compute compare, and interpret. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course. Okay? This is your teacher Torres saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!